Let's see if we can look at it like this. Are we going to do 1 through?
Sure.
I think what I want to do here is write these out rather than write them. I just had a student exactly the same kind of problems, and I discovered that I didn't have enough paper to do it. Unless I did it this. Now let me at least get it written. Oh, let's see. First problem is this program no longer syncs up, so it's hard for me to use. I can't erase with it. So we have the cube root of x times the square root of x to the 5th, all divided by the square root of 25 x to the, what is that, 16x?
Yes.
So do I have the problem right? Simplify each expression.
I'm not too sure how to do these, or where to start.
All right. Can't do anything with that yet. However, I can do a lot with this. What is the square root of x to the 5th?
Just, what is it? X times x times x times x times x?
Well, here's the way to do it. Factor it until you can pull out an x without a radical sign. So that's what it is. And what's the square root of x to the 4th?
Just x squared?
Yep. X squared times x squared is x to the 4th. Okay. So that's the answer to that part. Okay. Now let's go down and look at the denominator. We want to take the number first and then take the exponent second. So that's the square root of 25 times the square root of x to the 16x. So that's 5. Now, what is the square root of x to the 16x? What is that equal to? When you're taking the square root of a variable, you just divide the exponent by 2. In other words, the way we did that was we divided 4 by 2, 2 being the square root, and came up with x squared. So the square root of x to the 16x is x to the 8x. See how I got it? You still there, Sam? Or did I lose audio?
Oh, sorry, I muted myself on accident. Yeah, I'm here. There's no x in the exponent spot in the problem.
I'm sorry, what?
The x in the exponent spot?
Uh-huh.
It's not in the problem.
Ah. I thought that was a little advanced. So it's just x to the 8th.
So it's not, it wouldn't be x to the 4th?
No, you're going to take half of that exponent.
Okay.
Notice that x to the 8th, it always has to pass this check. If x to the 8th times x to the 8th is x to the 16th, then the square root of x to the 16th is x to the 8th.
Okay.
Okay, so let's put it all together. Let's see, I'm going to write over here on the lower right, that way I'll be able to scroll down. So I have the cube root of x times that, which is x squared square root of x, all divided by 5x to the 8th. Now, in order to simplify this, let's convert these to fractional exponents, because then we'll have the same base, and I can combine all three of these numerators, and then I can combine it with the denominator. Okay, so we got x to the 1/3 times x squared times x to the 1/2, all divided by 5x to the 8th. So what's the new numerator?
I'm not sure. I'm not sure.
Add the exponents.
Let's see. I don't know. You can put it all to the power of 6, or
2
you
sixths.
change the fraction to the
That'd be 2 sixths. That'd be 3 sixths. So 2 and 5 sixths. Bottom, I got 5x to the 8th. Now, how do you do that?
Would you change it to the same fraction?
Up here we were multiplying, so we added the exponents. Here
So just subtracting these?
So we subtract the exponents. So I end up with, and you can either put it to a negative exponent and then put it in the denominator, but the easier way is to just see that it's going to be x to the 5 1/6 in the denominator, and that's going to leave a 1 in the numerator. So make sure you understand how I go from there to there.
Would it be to the, so you're subtracting the 2 and 5 sixths from the 8th and not the 8th from the 2 and 5 sixths?
What we really have. This is what we have. 2 and 5 sixths minus 8. That's equal to x to the minus 5 1/6, which is equal to 1 over x to the 5 1/6 power.
Oh, so you're just having the negative on top and then you're flipping them.
Yes, whenever you have a negative exponent, that's what it means. It just means the reciprocal to the positive exponent. It does not mean a negative number. Everybody thinks that means a negative number. It doesn't. Or if you look at something like this, that's not a negative number. That's 1 over 2 to the 3rd, which is 1 over 8. It's almost always a positive number, in fact. So that's the way you have to do these problems, is step by step. Now, I could have made it a little simpler when I was over here. I had an x to the 2nd. I could have crossed that out with this x to the 8th and changed that to the 6th right then and there. Okay? And then I would have had x to the 5 sixths divided by x to the 6th. I still end up with x to the 5 1/6 in the denominator. Think you could read this one to me?
The one on the right?
Yeah. Is that what we want to do next?
Sure.
Okay.
It's the square root of x times y to the power of -2. And the y to the power of -2 is not in the, it's not in the square root.
Actually, I can write it. I see it now.
Okay.
I didn't realize I could put both of them up there. Okay, so it's x y to the negative 2 all over y x to the negative 7/4 all to the 4th power.
Yeah.
Now, the other thing about negative exponents is you can just take it to the other side. Okay? In other words, this y to the minus 2, I can make y to the positive 2 underneath. And this x to the minus 7/4, I can take on top. So,
And then
if I want to rewrite this, the easiest way to rewrite this is x to the 1/2. That's that square root of x. I'm going to put the x in the bottom in the numerator as a positive exponent. In other words, if I move it to the other side of the fraction bar, I change the sign on the exponent. In the bottom, I've got that y, and then I got that y. All that's to the 4th, but let's combine it. 1/2 plus 7/4 is 9/4. That's y cubed. And now how do you handle that 4?
Is it what? It's y cubed?
Yeah, y times y squared.
Oh, because there's the y times, yeah.
Yeah. So now what do I do? How do I treat that 4 up here? What do I do with that?
I'm not sure.
You multiply.
Okay.
Okay. So you'd end up with x to the 9th all over y to the 12th. Sam, let's go over the 3 rules for exponents. Can't forget those. These are huge on your SAT or ACT, anything. If I have b to the x times b to the y, I am multiplying same base. That means I am adding the exponents, which is one level less than multiplication. If I am dividing, same base, different exponents, I am subtracting the exponents. Notice I'm never doing to the exponents what I'm doing to the base. And the third rule is if I'm doing a double exponentiation, there's one, and I'm taking the whole thing to the y, well, that becomes b to the x times y. So the rule is that when the base is the same, you never do to the exponents what you're doing to the base. You always do one step below it. Multiplication becomes addition, division becomes subtraction, and exponentiation becomes multiplication. Okay? These 3 are critical. You need those at so many different levels of math. Now, there's 2 other situations. And that is where you have a different base to the same exponent. You multiply the 2 bases and take them to that same exponent. Same thing if you are dividing different bases, same exponent, then that becomes a over b to the x power. So these 5 rules cover all your exponent rules. Now, if I have a to the x times b to the y, in other words, if I have different bases, different exponents, can't do anything with it. That's simplified. Shouldn't put an x through it, but I can't turn it into anything else. Okay? So these 5 rules, very, very important. 3 rules where your base is the same, and two rules where your exponent is the same and the base is different. All right, let's go to the next problem. We're going to have to apply these rules on all of these problems. I hate Windows 11. I do. I hate loop path. Or rather, Windows 10. Just a second. And when it acts up, it's even more annoying. Okay, that should allow me to scroll down. All right, now I can minimize and hopefully see the problem. Yeah. Okay, so we got x, the minus 1/2, times y squared, all divided by, no, that numerator is all to the minus 5/4.
Yep.
Divided by x squared, square root of y, which I'm going to take a step and write that as 1/2. I'm going to work in exponents. I want to work in exponents. I don't want to work in a mixture of exponents and radical signs. And when you get to calculus, it's all exponents. You don't use radical signs. If you have a radical sign, the first thing you do is convert it, because the exponents are so critical in calculus. All right, so what do I want to do first here?
I guess you could move the x to the negative 1/2. Oh, you can't do that yet.
That all is being taken to the minus 5/4. So I kind of have to do the numerator first. So what's that turn into? What am I going to do to these exponents in the numerator?
You multiply the negative 5/4 into them.
Okay, so what's the x exponent?
I'm sorry, what?
In the numerator, what is the exponent on the x variable?
It's the negative 1/2 times negative 5/4.
Okay, that is positive 5/8. What's the y?
I'm not sure.
Multiply the exponents.
Just the 2 times the negative 5/4.
That's negative 10/4, which is.
So you're just multiplying the 2 into the. Okay, that makes sense.
Okay. Now, rather than fool with bringing that y and putting it in the denominator, let's just apply our rules. There's the same base division. So what is the net of that?
For subtracting?
5/8 minus 2.
Let's see. 1 3/8.
Okay, and I'm going to do this in 2 steps. It's a negative 1 3/8, right? And then do the y's.
It's just
minus 5/2 minus 1/2.
Just 2.
Actually, minus 5.
It's 6/2.
Okay, that's minus 3. Okay, so that's what that equals. Now, the one rule in math is you don't want to give answers with negative exponents if you can help it. And a lot of the teachers will say, make sure your answers all have positive exponents. So how do I write that with positive exponents?
Would you flip the x and the y into the denominator and make it 1 over that?
Yep. So, and in fact, I don't even like mixed numbers. I'm going to say 11/8 times y to the 3rd. And there we go. There's our answer, and it's got all positive exponents. Okay. Tackle this other one over here. X to the third. You can see that we're using the same three rules in each of these problems, right?
Mm-hmm.
We haven't even used the other two rules yet. All right. If I copied it right. What's the first thing we want to do?
The exponents on the outside of the parentheses, you want to multiply them out.
Okay, so let's do the numerator first. And I definitely suggest doing these one step at a time. You know, there's going to be spots where you could do 2 or even 3 steps at a time, but it's rare. That's a recipe for making mistakes. It really is. I'm a firm believer that you do the step that you know you're not going to make a mistake on. So what's the x in the numerator going to be?
Is it x to the 9/2?
And how about the y?
6/2.
And in the denominator, what's the x?
To the negative 1/4.
And what's the y going to be?
To the negative, isn't it negative 2/12?
Yeah, or negative 1/6. Okay. Now, keep applying the rules of exponents. What do we get for an x value? In other words, this part of it right here.
I'm sorry, what?
The part that I've circled, what's that equal to? X to the 9/2 divided by x to the minus 1/4.
So, let's see, you're subtracting it.
Yeah, so it's 8
18
fourths minus a negative 1/4.
So just the 19/4.
Okay. And how about
All right, for y?
this part?
All right, so let's see. It's 18/6 again, so just 19/6.
That's how you do it. It's just all a matter of knowing those three rules.
Mm-hmm.
And since we didn't end up with any negative exponents, we didn't have to move it down at all. What is this secret? That's number 5. We got. We can start this. You want to finish this problem? It won't take long, especially now that you're an expert at this.
Sure.
We can do this in 2 minutes. Dang, days. I don't need that dot.
Mm-hmm.
Multiplication is presumed if you don't have anything between variables. Okay. First step, what's the numerator going to be?
X to the negative 1/8. And y, just y.
Okay. What's the denominator going to be? Combine those x's.
So you're multiplying them, so you're just adding them, right?
So it's 2/3 minus 3/2.
So
6 minus 9/6, negative 5/6.
mhm.
And combine the y's.
Let's see the y. Okay, so the y's, it's just 2.
Okay, now do the x's. In other words, you can do these a variety of ways. I've merely taken the path. I could have handled no, that's the best path to take on this problem. It really is. Okay, so what do we got here? Now I've got minus 1/8 minus a minus 5/6. Common denominator, 24. That's minus 3/24 plus 20/24. That's 17/24. What's the y?
The y,
What's this part here?
just negative, or it's just 1.
Negative 1.
Negative 1.
Yep,
Yeah.
I'm going to write it in the numerator. But if they want the answer without any negative exponents, then it's x to the 17/24 over y.
Mhm.
There you go.
Thank you.
You're welcome. Sam, you have a good rest of your week, and I'll talk to you next time.
Mhm. Bye.